Hi, so in this video we're going to be looking at two special types of functions that are called odd and even, which you can see in the questions below. And what these have to do with why they're special is because there's certain functions that have a bit of symmetry to them, and there's two different types of symmetry, so we've got two different words to describe those symmetries. So what I'm going to do is show you an example of an even function and then an odd function, and then I'll go through the questions below in how to actually determine algebraically whether a function is even or odd. So first, for an even function, so what we'll do is graph x squared and this is an even function. Now why is that? Well, what type of symmetry can you see here? Whatever's on the right hand side, right, of the whatever's on the right hand side here is the same over here. So you'll notice this the y-axis forms a axis of symmetry here. So that's what an even function is. Even means it's got line symmetry over the y-axis, which I should probably label. Right. So let's investigate something to do with the values here. So, what's the black dot for? So, if we put in, let's look at, say for example, a value here and here. Notice they have the same y value. So we're going to look at a couple of values, right, where they're the same. So if we calculate, for example, let's say we put f of 1 into the function. So f of 1 squared is 1. But also, if we put, say, negative 1 into the function, f of negative 1, or negative 1 squared is also 1. So notice f of 1 and f of negative 1 are equal to each other, they're both 1. What about if we put 2 into the function? Well, if we put 2 in, we get 2 squared is 4. And also if we put negative 2 in, we get negative 2 all squared is also 4. So you'll notice that f of 2 and f of negative 2 are both equal. You can maybe see where this is going. Let's do another value. F of 3, when you put 3 into the function, 3 squared is 9. And when you put negative 3 into the function, negative 3 times negative 3 is also 9. So f of 3 equals f of negative 3. So notice here we had 1 and negative 1. We had 2 and negative 2. We had 3 and negative 3. So for an even function, right, if we put in a number and we put in negative that same number, right, so following the same pattern, x, just like 1, 2 and 3, negative x, negative 1, negative 2, negative 3. If we put in a number and the negative of the same number and they are equal to each other, right, then this is what an even function is, right? So graphically, an even function is if it's got line symmetry, you flip it over the y-axis and it perfectly lines up, right? And so all these values, right, all along the curve are going to have an equivalent value when you put in a value, and negative the same value is going to happen all along this graph. So for every value you input in here, x, and you put in a negative value, negative of the same numerical value, then you'll get, and you get the same thing. If that happens everywhere along the curve, then then this is an even function. So, how can we show this algebraically? Well, what we can do is we can say, so here's our function, f of x was x squared. What we can do is try inputting negative x into our function. So we're going to input negative x into our function, and if we put negative x into our function and we arrive back at our original function, then we can conclude it must be even. So if we put negative x into our function, that means everywhere we see x, so it's got x squared, everywhere we see x we're going to replace it with negative x. So if we do negative x squared is negative, a negative squared is a positive, and x squared is x squared. And what was x squared? It was our original function. So when we evaluate f of negative x, we end up back with f of x, our original function. So from that we can conclude, therefore, that it's even. Alright, the other type of symmetrical function is called an odd function. Right, and to do this we're going to look at the graph of f of x equals x. So this is just the graph y equals x. Pretend it goes through the origin. Try. Right, this is the line y equals x. So this graph here has some symmetry, but it's a little bit different, right? If you flip this over the y-axis, does this portion line up with here? No. But if you flip this over the y-axis, it goes to there. And then what about this line? If you flip this line over the x-axis, then this purple, right? So you flip it over the y-axis first, that would be an even function, but it doesn't line up, so it's not even. If you flip it over the y and then over the x, and it lines up down here, then that's an odd function. So odd is line symmetry over y-axis and then the x-axis. Or there's another way you can think about this, which is, what colour will I use? If you grab, right, fix the origin here, and then you, sorry, I've got to think about this. If you rotate, right, so here's our graph here. If you fix the origin, and then you rotate the top bit around 180 degrees, and it lines back up. So if you rotate that piece up here, the green piece, 180 degrees, and it lines back up with the other part of the function there, then it's also odd. So probably should have used purple to match up, but or we'd say it's got rotational symmetry about the origin. Right, so if you fix the origin and then rotate this top portion here around and it lines up perfectly with there, that's another way of conceptualizing graphically what an odd function is, right? So odd function is a bit more complex than even, because it's not a straight flip over an axis, it's like a double flip over two axes. Okay, so what do we notice about the values? So let's do something similar. Let's put in some values. So if you put in f of 1, well, this function is f of x equals x. So you put in f of 1, you get 1. What about if you put in f of negative 1? You get negative 1. Let's do the similar pattern we did with the parabola. When you put f of 2, you get 2. When you input negative 2, you output negative 2. When you input 3, you get 3. When you input negative 3, you get negative 3. So, notice here that they're not equal. You input 1 and you get 1. You input negative 1 and you get negative 1. You input 2 and you get 2. You input negative 2 and you get negative 2. You input 3, you get 3. You input negative 3 and you get negative 3. Now, notice this is the same as negative f of 1, right? Because f of 1 was 1 and this is negative 1. F of negative 2 is the same as negative f of 2. Negative 3 is the same as negative when we calculated f of 3. So the connection algebraically with an odd function is that when you input negative x into it, you output negative f of x. So that's the connection for an odd function. So let's try doing this algebraically. So f of x, our function is x. So what we're going to try doing, just like last time, is input negative x. So we'll input negative x. So everywhere we see x in our equation here, we're inputting negative x. So everywhere we see x, we're going to replace it with negative x. And that is, notice, negative, well, x here was, x was f of x, so negative x is negative f of x. So when you input negative x, you get negative f of x. So therefore we can conclude this is an odd function. Alright, so the general process to test whether a function is either even, odd, or neither is that you'll notice both times when I did it algebraically, I input negative x into the function. Input negative x into the function, and then if you get if it equals the original function, then you can conclude that it's even. If when you put in input negative x, you get negative the original function, then you can conclude that it's odd. And if it's neither f of x nor the negative f of x, it's not even or odd, it's neither. There's no obvious symmetry to it in the ways described for even and odd. Okay, so now I'll go through these questions over to the side following this process. So we've got f of x is 4x. So to test whether it's even, odd, or neither, if there's any symmetry about the graph 4x, we're going to input negative x. So let's input negative x. So everywhere we see x, we're going to replace it with negative x. 4 times negative x is negative 4x, and that's, you'll notice, 4x was the original function. So it's negative the original function. So we input negative x. F of negative x equals negative f of x. So therefore this is an odd function. Right, so that means if we were to graph this, then if you go flip-flop over both axes, then it's going to line up perfectly, or if you rotate it 180 degrees around the origin, or if you rotate it pi for those playing at home in radians. So question 2, we've got the function is 2x to the 7, so we're going to input negative x, so everywhere we see x in the function. So here x is raised to the power of 7, and we're going to replace it with negative x. Now if we do a negative to an odd power, right? So imagine we had like a negative cubed, right? Negative times negative times negative. All the even ones are going to cancel out, and because it's odd, there's going to be a leftover one. It's going to be negative 2 still going to be there, and x to the 7. And you'll notice we've got 2x to the 7 was our original function, but we've got our negative here, so it's negative the original function. So when we input negative x, we get negative f of x, so therefore this function is odd as well. F of x is x cubed plus 5. So again, we're going to input negative x. So everywhere we see x, so the only thing happening to x here is it's being cubed. If we put in negative x, like I just said, this would be negative x cubed. Now, let's just look here, what would negative f of x look like? Well, negative f of x would be negative the whole thing, x cubed plus 5, which then if you distributed the negative through the brackets would be negative x cubed, and negative times plus 5 is negative 5. But this is not negative 5, is it? So it's not equal to negative x cubed. Is it the original function? No, it's not the original function. It's also not negative of the original function, so it's not even and it's not odd. So therefore it's neither odd nor even. Right, so I would be checking that like I did here for the negative f of x, because you might get confused and go, oh yeah, x cubed plus 5, oh yeah, I've got a negative x cubed, but the whole function is x cubed plus 5, which if you chuck a negative out the front is negative x cubed minus 5, and we didn't have minus 5 there, did we? Right, so a common mistake people might make there. Alright, x cubed plus 3x squared. So let's input negative x. So everywhere we see x, so we've got x cubed plus 3 times x squared in this equation. So everywhere we see x, we're going to replace it with negative x. Negative x cubed is negative x all cubed is negative x cubed. Plus now negative x squared is going to be positive x squared. So again, is this equal to the original function? Nope. What would negative f of x look like? Well, it would be negative x cubed plus 3x squared, which would be negative x cubed minus 3x squared. Is that the expression we have when we input negative x? No, it is not. We don't have negative f of x either, so it's not odd. It's not odd nor even. I'll just write neither for now for efficiency. Next one, 5. X to the 4 plus 3x squared. So again, we're going to input negative x. So we've got x to the 4 plus 3 times our input squared. So we're going to input negative x. So negative x to the power of 4. Well, x to the power of 4 is x to the power of 4, and a negative to the power of 4. Each pair is going to cancel out for the negatives and become positive. So it's going to be positive plus 3, and negative x squared is going to be positive x squared. which you can see when we input negative x, we get back our original function. So this one would be even. So if you graph this function, x to the 4 plus 3x squared, then it would be symmetrical, flipping over the y-axis. Alright, 6. What? We got 6x cubed on x squared plus x to the 4. So to test if there's any symmetry, we're going to input negative x. So up in the numerator, negative x cubed is going to become negative. A negative cubed is still negative, and on the denominator, negative x squared, it's going to be positive x squared, and because it's an even power, x to the 4. Now, is this the original function? No, it's not, because the original function didn't have any negatives, so it's not the original function. We've already checked that. Now, is it the negative of the original function? Back up here, right? Notice we had x cubed and then a number, and when we distribute it out across the brackets, we didn't have that minus. Same thing here. Here we had an odd power and a even power there, and it wasn't even. But you can't just go, oh, it's got an odd power and some even powers, therefore no. We still need a test like we did. Well, what would negative f of x look like? It would be negative the whole fraction. And if you've got negative of a fraction, right, so for example, think of like negative a half is the same as negative 1 over 2. Negative this fraction is the same as negative the numerator over the denominator. So when we input negative x, we actually do get negative the original function, which means that this one would be odd. Okay, last one here. F of x is 2 to the x, so this is going to look a bit different. We input negative x, so everywhere we see x we put negative. Now 2 to the negative x, well, what happens with a negative power? Negative power is the reciprocal, so 1 over 2x with a positive power. So is that the same as the original function? No. Is it the same as negative the original function? Well, negative of the original function would be negative 2x. Is there any negative in this fraction? Doesn't look like it. It's just 1 over 2x. Everything's positive, so it's not equal to negative f of x either. So therefore it's neither odd nor even. Right. So if you do know what these graphs look like, it can be helpful, right, to visualize it or draw a little sketch. I drew this in the last video. 2 to the power of x when we're doing domain and range, is a exponential graph. There's no symmetry about it across either of the axes, right? So think of, if you can recognize what the equation is, right? To be honest, I don't know what 6x cubed over x squared plus x to the power of 4 looks like off the top of my head, right? But if you do know, for example, that it's like up here, a straight line, or a straight line that's passing through the origin will be an exponential won't be, a quadratic graph may be even, right? So feel free to sketch them, try and have an idea both conceptually and visually what these look like, and then be able to follow the algebraic process of inputting negative x and then seeing what you get. Alright, that's it. Bye.